Down cold. So here we go. I'm going to shorten this up a little because of the short periods and because I want to make sure we go over set 99. So here we go. How could I show why tangent's antiderivative is log of secant? We've done that before. How is it done? U sub, yes. By first making it sine over cosine and letting u equal sine or cosine? Cosine. Therefore, du is negative sine. That means that you get a negative du when you sub for sine of dx. Doesn't this then become negative 1 over u du? Antiderivative, that is negative natural log of absolute value of u plus c, which is negative log of absolute value of cosine plus c. But rather than write it as a negative log of cosine, it's more common that you would call that a negative 1 and use log rules to bring it up so that it's log of cosine to the negative first. Be careful. Is that notation signifying inverse cosine or reciprocal of cosine? Reciprocal of cosine. And so that is where we're coming from, log of secant. Would you try the other one then, using the same principle, so that you have cotangents proven and in the books? Same idea, but actually a little cleaner. Okay, this one's actually even easier because there's no negative, yeah? So, in the interest of time, I'd like you to have it memorized and know where it comes from. Is that doable? Are we good? Okay, let's go on then. Now, something we haven't played with a lot is powers of tangent and cotangent. Now, you will need to draw in a couple different fields of knowledge. First of all is identities. You're going to need to know your Pythagorean identities. Tangent squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. You might also need to remember your derivative facts. What's the derivative of tangent? Secant squared. What's the derivative of cotangent? Negative cosecant squared. What's the derivative of secant? Secant tangent. And what's the derivative of cosecant? Negative cosecant cotangent. Yeah? Okay, now let's look to use those to work our way out. Look at tangent squared. First of all, let's hope for the easiest case. Is tangent squared just a known derivative of something already? Not really. That's not a derivative that pops up anymore. So, do you have any ideas of what we could do then? Secant squared, I heard. Yes, let's use an identity. What's tangent squared equal to? Secant squared plus 1 or minus 1? Minus 1. Does that help you get going? Yes, it should. What's the antiderivative of secant squared? Tangent, yeah? That is a known derivative. It's tangent. And what's the derivative of negative 1? Negative x plus a c on there, and you're good to go. Tangent minus x plus c. Are we cool? All right. Try cotangent. Actually, in the interest of time, let's go together. When you see odd, what do we typically do? Separate it into cotangent squared and cotangent. That makes it a lot like sine and cosine. Then we typically try to use an identity. What's cotangent squared like? cosecant squared minus 1, yay? All right, let's distribute and separate. So I got your cosecant squared, cotangent, and your cotangent. Two integrals. If I separate it, is that allowed? Can I separate a sum in an integral? Can I separate a product in an integral? Okay. What is the antiderivative, or what are you thinking cosecant squared cotangent on? What approach? It's a product. Is one the derivative of the other? If that's the case, then you use sub. So it's a product. Is one the derivative of the other? Yeah, you actually could do this two ways. You could say, well, if I let u equal cotangent, then du is negative cosecant squared. It would work with a negative, right? However, you might also see, if you are super smart and awake, that you could use one of these cosecants and let that be u, and then the cosecant cotangent, that could be your du. And that works too. There's so many ways here. The only difference would be the constant would be different for those two cases. But which one do you want to use? Let u equal what?
Cotangent.
Cotangent. All right. If u is cotangent, then du is? Negative cosecant squared. Therefore, negative du is cosecant squared. So after u sub, what does it become? Negative u du. And that's negative u squared over 2, or negative, what was u? Cotangent squared over 2 for the first antiderivative. The second one, we just learned that. You have a really bad short-term memory if you don't know how to antidifferentiate cotangent. Just shift your little eyeballs to the top of your paper. What's the antiderivative of cotangent? Log of sine. What if that multiple choice wasn't there and that negative wasn't there? What can you imagine as another multiple choice? Instead of negative log of sine, what might you also see? Positive log of cosecant, yes, as a possibility. All right. Are you with me? Are you doing okay? Am I? Oh, sorry. I'll let you catch up. Take this time. Yeah, you good? No, Max and I go with me the whole time, so never mind that. Are you good? Okay, see? So there we go. Okay. Sorry. Tangent to the fourth. Are we ready? Cool. Tangent to the fourth is a little larger than I would like, so I would like to bring it down a little to the level of what I'm used to, squares and such, maybe. So let's go with tangent squared and tangent squared. What do you say? What do you say? Sounds good, Mr. Rickman. Let's do that. Okay, boom. You have any ideas of what to do now? You should know. It's pretty logical. Just think, what could I try? Secant square, okay. Should we go identities on both of them or just one? I think both would take me right back to secant to the fourth, and that's a step backward again. So let's go with just one of them and see where we're at. So what's tangent squared equal to? Secant squared of 3x minus 1. And we're going to leave 1 as tangent squared of 3x, all right? All right. That seems like we're getting somewhere. If I distributed, I'd get one integral of secant squared 3x tangent squared 3x. And I like the looks of that. Do you see how you would go about that one? What would your approach be on that? U sub. U as tangent or secant? Tangent. You could let u equal tangent, then you'd have u squared for the tangent squared, and that would serve as your du. Then we'll have to work out the 3 and all that stuff, right? Are you with me? All right, so that one feels good. Over here, we're going to have tangent squared of 3x. And that'll take a little different of an approach. Should we preview that, or should we just start rolling with our u sub on this guy? All right, so what should we let u equal? Tangent of 3x, not tangent squared, just tangent. No, not dx either. Okay, what's the derivative of that then? Secant squared 3x times a 3, so 3 secant squared 3x dx, yeah? Now we have the secant squared. What's the technique of dealing with that extra 3 we don't want? Divide it out, so du over 3 is secant squared of 3x dx. That's that good u sub skill. So when I take that to its conclusion, it becomes something like u squared times du over 3 after substituting, right? What's the antiderivative of 1/3 u squared? 1/9 u cubed, and let's just go ahead and sub back. Instead of u cubed, it would be going back to tangent cubed, okay, which you could write that cube after the tangent before the 3x, or if you put it outside, that's fine too. But I'm getting 1/9 tangent of 3x quantity cubed, right? Okay. How about tangent squared of 3x? What do you think there? What? Yeah, so is tangent, can we just go straight out to log, or is that more like the identity? Do we do a tangent squared already? Yeah, we did. How do we do it? We used an identity first. So call tangent squared secant squared of 3x minus 1, yeah? If I take that separately, that's negative secant squared of 3x dx plus the integral of 1 dx, yay? For the secant squared of 3x, that's kind of a function within a function. I know it feels kind of like tangent, but then what about the 3x kind of part of it, right? So do you want to mental use of this to deal with that 3x, or actual use of it? All right, so I think do you agree that the antiderivative of the secant squared is definitely tangent of 3x, right? The only question is it 3 tangent of 3x or 1/3 tangent? 1/3 is what would work with the derivative, right? Okay, so 1/3, is it positive or negative? Negative 1/3 tangent of 3x, and again, that checks out. If I took the derivative on that, I would get that secant squared of 3x. And then plus x close to c, and we're done. That was close to c on that. You with me? All right. In the interest of time, I usually let students fail miserably here because this one requires creativity. But in the interest of time, I'm going to throw you a bone here. The antiderivative of secant, all the different thought processes that probably went through the heads of those trying to find this antiderivative 400 years ago, I imagine they said, well, first of all, secant's not the derivative of anything, so it's not easy there. I imagine then they tried 1 over cosine, and that took them nowhere. There's nowhere to go from there. I imagine then they said, well, shoot, if it was secant squared, that'd be great. So I would bet they multiplied by secant over secant, but that really just kind of brick walls. That doesn't go anywhere. So the beauty of math is the creativity at the highest levels. And what got them rolling is multiplying by secant plus tangent over itself. Obviously, you must keep the expression balanced. Now that's okay mathematically because we just multiplied by 1 and we know we can always do that. Now what that does for you in the numerator is gives you what? Secant squared plus secant tangent. And in the denominator is secant plus tangent, okay? Now that is pretty cool because now it does. How would you proceed from there? U sub. What should we let u equal? Secant plus tangent. When you take du then, the derivative of secant is secant tangent, and the derivative of tangent is secant squared dx, and although it's in the wrong order, that's okay because it's summations or additions. So it's du over u, yay? When you anti-differentiate, that's natural log of the absolute value of u plus c. And then subbing back, it's the log of secant plus tangent. Now this is, I'm not big on memorization, but this is probably one you want to memorize because if you, it's as opposed to the tangent one, which is u sub, and most people can come up with that on their own. This is not one you're likely to come up with under pressure in a test. You probably want this memorized, okay? Are you with me? With that said then, what do you reckon we're going to do to get cosecant, which is a lot like secant? Hi. How you doing? Nice to be back. I didn't know people were those people. Should I give this to fourth period? Because this kid's in fourth period.
Yeah.
Should I just hold up to it?
Yeah.
Okay. All right. So what do you reckon I'm going to multiply by? Cosecant. Now, it's a good idea. Last time we multiplied by secant plus tangent, right? So it would be logical here to multiply by cosecant plus cotangent. And let's see if that'll work or if we're going to have to play with this a little because we know that these guys have negatives going on, so maybe this will work, maybe not. We'll see. If I do, that'll become cosecant squared plus cosecant cotangent. Are we down? Over cosecant plus cotangent. Now if I let u equal cosecant plus cotangent, what's the derivative? What's the derivative of cosecant squared, or cosecant? Negative cotangent, no, negative cosecant cotangent, right? Do we agree?
Yes.
And what's the derivative of cotangent? Negative cosecant squared. That's kind of like I have up there, but with a negative du, that is cosecant x cotangent of x plus cosecant x, yeah? Square root of x. So upon substitution, this is negative du over u. It's actually not how it's typically done. The problem then is you have a negative. That's, I mean, it's fine. What you're doing is fine, but it wouldn't be there as a multiple choice. It's not the classic form. So, sorry. For reasons of simplicity, you're about to be headed for a log of cosecant plus cotangent with a negative out front, and who wants a reciprocal of that sum and all that. So that's just not how it's done. Would you go back and change this to cosecant minus cotangent? That's how it's typically done. I apologize for not just making you do it that way to begin with. Sorry. Negative cosecant minus cotangent. Now, if you then do that, you get cosecant squared in the top minus cosecant cotangent, and in the bottom, cosecant minus cotangent. Are you seeing where I'm coming from? Now that u equal cosecant of x minus cotangent of x, therefore du is negative cosecant cotangent. Also, we have it negative up at the top, plus cosecant squared, right? Dx. So it is then du over u, natural log of u, natural log of the absolute value of cosecant minus cotangent. Are you with me, people? Great. Okay. That then is what you should have down called cosecant is log of cosecant minus cotangent. Secant is log of secant plus tangent. Tangent is log of secant. And cotangent is log of sine. And then you also need to have the identities and even and odd to be able to work those out. All right. You with me? Yeah. But you're young, you have awesome short-term memories, am I right?
No.
Oh, you best.
Guy.
I would personally focus on the ones that are conceptual myself, okay? So I'll take that for what it's worth. The ones that I would probably throw at you are the ones that you could come up with on your own without memorizing them. So I'll just leave it at that, okay? Question on 99, which the key I did, but I forgot to post. We get out of here at 11:30, so we have 20 minutes or so to go to questions. So let's get 99 knocked out at least. 22, 3, 22, 3, 1, 6, 14,
21.
20,
Yeah. We didn't have to do numbers. Oh, we didn't.
20 you can skip, sorry. My bad. Okay, 22. What do we got there? I did 22. Must have thought it was easy. All right, did you draw a picture of 22? Why not? Because here's a buoy. First of all, it's fun to draw a picture of a buoy. Second, it's not a party hat, it's a buoy.
Yeah, obviously.
Everybody's smart for that.
Oh, now it's a party hat in the ocean.
No, it's not a party hat in the ocean. Obviously, it's a party. There's a shark there. Obviously, it's not a party hat. Why would a party hat be? That's ridiculous. All right, so anywho.
Did you put stripes?
Yeah, stripes. Oh yeah. No, that's so we've got a couple boats going around. Two boats leave a buoy at the same time. One travels due north at a rate of 10 miles per hour. The other travels east at a rate of 4 miles per hour. Probably going 4 times as fast in the same amount of time then, yeah? Or 4 times as far away. At what rate is the distance between them changing 30 minutes after the boats leave the buoy? So what's the distance between them? Well, that is a right triangle, yeah? So let's call that, what did you call every stuff? Did you call it northeast and distance, or what did you call stuff? Distance,
No.
X and Y?
No.
Alrighty, what then? East?
Yeah. No.
East and north. Sounds good. Okay. Now, those represent distances, not rates. E represents the distance from the buoy. So when it says it's traveling north north is terrible because they use N for something else. That's the worst. X and Y it is. Okay. When it says it's traveling north at n miles per hour, then that means dy dt is the rate of change in y with time, and dy dt is 4n, yes? No, n. Why'd you say uh-huh? Dx dt is 4n. We? All right. They want the rate of change, that's given. They want the rate of change in the distance between the two boats. That means, what's the rate of change in d? dd dt when time is 1/2, not 30. Units. It's in miles per hour. 4 miles per hour. Changing in 30 minutes needs to be 1/2 an hour. All right, so here we go. What's the relationship between the 3 variables?
D is equal to square root of x squared.
All right, so you can go either square root or just straight up Pythagorean theorem. I'm not sure which is easier. Let's just go this way, shall we? Now, what should we differentiate with respect to? Time, yes. So if I differentiate with respect to time, then what's the derivative of the left? 2d dd dt. What's the derivative of the right? 2x dx dt plus
Two
2y dy dt. Do you agree that we could drop a 2 out of everything, or divide a 2 out? dv dt then is x dx dt plus y dy dt over d. Now we just have to plug in the instant they talk about. They say what's going on a half an hour later.
Oh,
Are you with me? All right. So in a half hour, what's x? What's its rate? 4n. It goes 4n miles every whole hour. So in a half hour, what's x? 2n. What is dx dt? 4n. In a half hour, what's y? It goes n miles every hour. So in a half hour, it'll go n over 2. What is dy dt? N. And what is the distance between the two after a half hour, given that this is 2n and this is a half n after a half hour? What is d? Square root of 4n squared plus n squared over 4, right? Which is 16n squared plus n squared all over 4, or 17n squared all over 4, or root 17n over 2. Root 17n over 2 is 8n squared plus n squared over 2 all over root 17n over 2. You with me? What's the top? 16 plus a half, so 17n squared over 2 times the reciprocal 2 over root 17n. The 2's divide away, and n divides away. So I feel like 17 over root 17n. Or you could even just say root 17n if you simplify that. Alrighty. Are you with me? Super. What if there's an easier way to do that? Okay, how about 3? Is the 3 still a question? 3 yes, 3 no. Okay, so this differential idea, if you go away from the science part of calculus and go to the business calculus side, if you become a business major person, this idea is a big one. It's called marginal profit or marginal expense or marginal this or that, marginal cost. And marginal is like the cost of one more, which is what differentials tries to estimate often. So, P of x is 750x minus 2x squared minus x squared minus 99x plus 4,000. And I would imagine that's probably revenue minus expenses. Differentials to estimate. The change in profit when x changes from 125 to 130 is the idea. Hi. Hi. So I would say that delta y yes, start with third hour tomorrow. Okay, so the differential idea in its most basic form is this, and then you take it to the problem you're working on. So in this case, there's no y. So what's here instead of what? Instead of saying change in y, you're saying change in p. true change in P can be approximated by dP, and dP is P prime times dx. What is P prime? Negative 6?
Oh.
What? Here's P, 750 minus 4x minus 2x minus, oh, you're distributing the negative, I'm down, plus 99. I agree with that. At what value? At an x of, which is the initial value, 125 or 130? 125. And what is the dx, or how much are we changing x by? 5. So all that said then, this is something like, what do we got? 750 plus 99 is 849 minus 6 times 125 times 5. Which we got there, that's 600 plus 150, 750. So I'm feeling 99 times 5, is that right? So I feel like by increasing our production by 5, we will gain approximately $495 in profit, extra profit, more profit. Right? That's the change in profit estimate. Are we cool? That wasn't so hard, was it? No, it wasn't. Number 1. Is one still question?
Yeah.
Did you get a picture? Okay, what does 9 minus x squared look like? Parabola shifted out. Open it up 9, and with the intercepts at 3 and negative 3, right? Or shifted up 3 and opening down. What about x squared minus 1? Down 1, opening upward. We're trying to get a rectangle in here. Now there are many rectangles we could get in there. We could do tall and thin. We could do wide. But there is a best rectangle to estimate, or area. So let's try and talk about what we're trying to maximize. We're trying to maximize the area of the rectangle. You can't maximize the area of the rectangle until we have an equation for the rectangle. What's the area of a rectangle? Base times height. Great. What's the base here of all those rectangles? The base is always changing. It could be thin, it could be fat, so it's varying. It's always x or 2xy. You could actually do this problem either way and get it right, but it is technically 2xy. Right? What's the height? Here's the height, here's the height. The height in terms of upper minus lower, the upper always seems to be a point on the upper parabola, the lower seems to be a point on the lower parabola. So the height is the difference between the two, yay? So the upper curve, 9 minus x squared, minus the lower curve, x squared minus 1. Cleaned up before we do our calculus, I feel like that's 2x times 10 minus 2x squared, or even cleaner, 20x minus 4x cubed is the area. Now you should be good. Find where a prime goes positive to negative for a maximum. Okay, one check. 6. Question on 6. 6, yes? How do you find work? Work is force applied over a distance, yes? Now, if the force is changing, like in a spring case, for example, is a classic, then you have to make the sum of many little calculations of force. That then is the big idea. Work is the sum of the force over distances, where the force is given. It's 1/2 x squared. And you're moving it from the origin, 0 to x equals 6. And that's it. Do that, you're on your way. 14, does anyone need 14? Yes, 14?
Yeah, I did that right.
Oh, excellent. I'm glad you remember it. It's been a while. 14.
I also never learned that lesson, so I was pretty proud of myself.
No, that's pretty great. The absolute max of F is 4. It helps if you just make a little noodle, which at x equals 2, here's the max of the curve beforehand. The absolute mid is -6, which happens at -3. This is F. Don't know really what else is going on. But then they tell me that if you took the absolute value of F, what would happen? And the question being, what's the absolute max? Well, what would happen to that 4 if it was positive already? Stays the same. But what happens to this one at -6? It gets moved to +6. Now, if that was the absolute mid, and that absolute mid is now greater than the previous absolute mid, now the absolute max is what? Okay. 18 was particularly the hardest surprise to me in this part. Or maybe you got it. I don't know. Okay, that's it. Let me know if you have questions. Usually students have a hard time figuring out how to separate that, but maybe you did. Okay, questions on 100. 50. 2 or 22? 2.
Mainly just
15.
it's a replacement.
15, does that replace or straight up?
Replacement.
Replacement. Alrighty, here we go. 15.
I have a lot of questions for your systems. 15. 20. Do you want number 20?
Okay. So, sure. So, this is real life application of cross section. So, the river the distance across the river at different points along the river from the bridge is given below. The shape of the cross sections is roughly semicircular. Estimated volume of the water in the river to 0.50 meters using a left sum. So let's look at this as x of 0. At that point, this is distance across is 20. 10 meters downstream or so, it's now 24. 20 meters downstream, now the distance is 26. 30 meters downstream, now the distance is 18. 40 meters downstream, the distance is 14. And 50 meters downstream, the distance is 16. Okay. Now, it's a bit of obviously it's a gross estimate, but they're saying that this is roughly semicircular here. And when I say a left-hand sum used to estimate the volume is going to be then the sum of many cross sections, yeah? Now, if I use the left-hand sum, the first one I'm going to use is this. So imagine if it stayed 20 throughout, what's the volume of that cylinderish kind of thing, yeah? All right, now, in every case, isn't this going to be one of those cross sections of a half circle? Do you remember the process there? Pi over 8 of the diameter squared dx, which is actually going to be a delta x here. So I'm going to call this a pi over 8 out front. The first diameter I'm going to use is 20, and then multiply that by a delta x. Is delta x the same all the time that I can factor it out? Yes. So you can actually factor that out front too. And that should be fun. Have a good day. 99 definitely should be turned in today, not 100. Have a nice day. Be nice people.
So are we sure if you can get turned into
Are we turning what?
Yeah, because
Yes. Have the pretest done when you walk in tomorrow, or you're a total weasel. Ah, darn it. I did. There goes a half hour after school. That's if we record anything. Did I? Oh, did I record it?